Questions 11 through 20 on the 2007 Grade 11 Fermat Math Contest. 5 numbers in increasing order are 2, 5, x, 10, and y. The median of the numbers is 7, and the mean is 8. The value of y is 2, 5, x, 10, and y. Those are our numbers, and they immediately tell you that the median, which is the middle number, is 7. So there you go. All we need to do now is figure out y. The average, they tell us, of these numbers is equal to 8. So figure out the average, add the numbers, divide by how many numbers there are, which is 5, and you get 8. Cross multiply, you get 40. And if you add these numbers up, you will get 24. And that's plus y. So therefore y is equal to 40 minus 24, which is 16. So number 11, the answer is A. In the diagram, PQ is equal to 10 and QR is equal to x. The value of x is. In this diagram, you'll notice that this angle and that angle are the same. So that means that this side and that side must be the same. That's a property of isosceles triangles. So if this side is x, that means this is x also. So I'll write that in there, x like that. Now we have to look at this triangle right here. In that triangle, we are given 2 angles. That is a right angle, 90 degrees, and that is 60 degrees. So therefore, this angle must be 30, since the sum of the angles of a triangle add up to 180. And then in any 60, 30, 90 triangle, the ratio of the sides are as follows. The angle opposite of 30 degrees is 1. The angle opposite, the side opposite 60 degrees is root 3. And the side opposite the 90 is 2. That is the ratio of the sides, not necessarily the length. So now we can use those ratios to figure out x. X over 10 is equivalent to 2 over 1, right? This over this is equivalent to the ratios, which are 2 and 1. So there you go. You solve for x now. Cross multiplying gives you x is equal to 20. And therefore, number 12, the answer is B. In the diagram, each of the numbers 0 through 7 is to be used to label a vertex of the cube. The numbers 0, 2, and 3 are placed as shown. The sum of the numbers at the ends of each edge must be a prime number. Note, 1 is not a prime number. The value of m plus p plus q must be. Let's experiment with this. First and foremost, I'll write out the numbers 0, 1, 2, 3, 4, 5, 6, 7. And immediately we will get rid of the numbers they've already placed, which are 0, 3, and 2. Those numbers have already been accounted for. All right, so let's see what we can do here. The numbers along any edge must add up to become prime number, right? The sum of the numbers at the ends of edges must be a prime number. All right, so let's see what we can do. Wherever you'd like to start, I'm going to start right here with r, since it's at the bottom. 0 plus r must be a prime number. Okay? So what can r be? Can r be 1? No, because 0 plus 1 is 1, and 1 is not a prime. 0 plus 4? Nope. 0 plus 5? Yeah, 5 is a possibility. That would work. 0 plus 6? No. 0 plus 7? 7 is also a possibility. So for r, it can be either 5 or 7. Now if it's 5, 5 plus 2 would be 7, and that would work. But if it's 7, 7 plus 2 is 9. That would not work. So therefore, r must be 5. So there we go. We got r. Now let's concentrate on the top right here. Well, I've got r, so I might as well just work with r. I mean, you can do this in any order you'd like. It doesn't really matter. Or you can go with q or p. So whatever. I'll just go with Q since I like the smaller numbers, makes it easier for me. 3 plus Q has to be a prime. So let's see what I have left. I've got 1 left. If I put 1, that doesn't work. 1 plus 3 is 4. If I put 4, 4 plus 3 is 7, that does work. If I put 6, 3 plus 6 is 9, that does not work. And if I put 7, 7 plus 3 is 10, that does not work. The only one that works for Q is 4. All right, great. Let's keep going. Let's try P now. With the numbers that are remaining, 2 plus 1, that would work. That is a prime. 2 plus 6 is 8. That does not work. And 2 plus 7 is 9. That does not work. So P must be equal to 1. All right, great. How about N now? Let's see. 1 plus 6 is equal to 7. That would work. And 1 plus 7 is 8. So this must be a 6. And then basically, by process of elimination, that is 7. So now let's figure out the value of M plus N plus P plus Q. That is going to be 7 plus 6 plus 1 plus 4. And that is equal to 13 plus 5, which is 18. So number 13, the answer is 18, which is choice C. Two positive integers, a and b, have the property that if a is increased by 25%, the result will be greater than 5 times the value of b. What is the minimum possible value for a plus b? So we have a, and we are increasing it by 25%. So we are basically multiplying by 5 over 4. And if you do that, it's greater than 5 times the value of b. So this is basically the setup for the question, the inequality. Working with this, cross multiply the 4 and you get 5a is greater than 20b, and therefore a is greater than 4b. Now they want the minimum possible value of a plus b, and both a and b are positive integers. So what's the smallest positive integer I can choose for my value of b? Well, it's got to be 1, right? So if indeed b is 1, a must be greater than 4 times 1. A must be greater than 4. So what's the smallest possible minimum value I can choose for a now? That is a equal to 5. So there we go. I chose 1 for b, and that led me to get 5 for a. So therefore, the minimum possible value of a plus b will be 5 plus 1, which is 6. So number 14, the answer is B. How many 3-digit positive integers x are there with the property that x and 2x have only even digits? One such number is 420 for x and 2x equal to 840. And each of x and 2x has only even digits. It is a 3-digit number, correct? And first and foremost, what are the even digits? Well, there's 0, 2, 4, 6, and 8. Those are the only choices that we can use. So no 1, no 3, no 5, no 7, no 9. Okay, so for the first digit of this 3-digit number, my choices are either 2, 4, 6, or 8, right? Can't be a 0 because if it's 0, it's not a 3-digit number. For my second digit, I can use a 0. That's not a problem. And 2, 4, 6, 8. And very similarly, the third digit, you can also use 2, 4, 6, or 8. So first, let me just figure out how many of these will be created. We got 4 choices for the first, 5 for the second, and 5 for the third. So you multiply 4 times 5 times 5 is 100. Now 100 is one of the answer choices, but hold on for a second before we choose that, because that would be wrong. This 100 reflects all the 3-digit numbers that have only even digits. Fine. But we have to create numbers where 2x also only has even digits. Okay? So if the question was just x, the answer would be 100. But the question is x and 2x. So we immediately cross out 100. I can also cross out 125 because obviously my answer is going to be less than 100, right? Because there's several of these that I have to eliminate. All right, so here we go. How do I eliminate? Well, think about 2x. So this was a scenario for x. Now we got to think about 2x. If any of the numbers or any of the digits is a 0, if I multiply it by 2, it will be 0. So that's not a problem. Same thing, if any of the digits is a 2 in x, if I multiply it by 2, then it'll be 4. That's not a problem. 4 becomes 8, again, not a problem. But 6 becomes 12. And that is a problem because 12 contains the digit 1, which is not even. And similarly, 8, when you multiply it by 2, becomes 16, and that is a problem also. So the 6 and 8 cannot be used when we take into consideration that 2x also has to have even digits. So that means if I have a 3-digit number, for the first digit, I can use only 2 or 4. 6 and 8 cannot be used. For the second digit, I can use 0, 2, or 4. And for the third digit, again, I can use 0, 2, or 4. So now I've got 2 possible choices for the first digit, 3 for the second, and 3 for the third. 2 times 3 times 3 is 18. And that is the correct answer, where both x and 2x will only have even digits. So number 15, the answer is 18, and that is choice B. In the diagram, each of the 3 squares has a side length of 3. 2 of the squares have a common vertex O, and O is the center of the square labeled ABCD. The perimeter of the entire figure is closest to. Let's label this figure. We are told that the square has a side length of 3, so all of these are 3, including AD, because they tell us that those squares, all of them have a side length of 3. So there you go. Those sides we just identified immediately. But now we got to worry about these guys here. Those sides, those lengths. Because of the symmetry of this diagram, all of those are equal. So I'll just call them x. So that's x, and so on. So the perimeter basically is 1, 2, 3, 4, 5, 6 of these 3's plus 4 of these x's, which is 18 plus 4x. If I can figure out the value of x, I'm done with my question. So here we go. How do I figure out x? Well, one thing I immediately noticed is that x is basically this side, which is 3, minus this right here. If I can figure out that distance, I can subtract it from 3, and I've got x. So how do I figure out that distance? Well, that distance looks like it's half of the full diagonal of that square, right? Whereas this whole thing is the diagonal. You can call it d. So the diagonal should be pretty easy to figure out. We can use Pythagoras using these sides. All right, so here we go. This side is 3, that side is 3. So therefore 3 squared plus 3 squared is equal to the diagonal squared. And the diagonal in terms of our letters is BD, the distance from B to D. I'll just write that in brackets. So that means this is 18 is equal to D squared, and D is equal to the square root of 18, which is 3 root 2. Now this distance right here is the diagonal divided by 2. So that is going to be 3 root 2 divided by 2. Okay? So therefore x is essentially the length of the side minus this 3 root 2 over 2. So the length of the side was 3 minus 3 root 2 divided by 2. All right? So there you go. So now I can go back and plug it in. 18 plus 4 times x. X is 3 minus 3 root 2 over 2. And the good news is that we can just figure out the actual decimal value. And when you do that, you'll get approximately 21.5. And therefore, number 16, the answer is A. In the diagram, A22 and C84 are the two vertices of an isosceles triangle ABC. If the vertex B is located on the x-axis and angle ABC is 90, the x-coordinate of B is. So this is 84C, and A is 22. And B, we don't know, it's something, it's x0, because it's on the x-axis, right? So the y-coordinate is 0. So we have to figure out x. So how do we do that? Well, first thing that they give us that's very helpful is that ABC is 90 degrees. So if that's 90 degrees, then that becomes a right angle. And because it's a right angle, we can use Pythagoras. Now Pythagoras, but how though? We don't know the length of this side, nor do we know the length of that side. But we can use the distance formula. We have coordinates. So here we go, AC, the length of that's probably the easiest one since we have numbers. It's 8 minus 2 all squared plus 4 minus 2 all squared, all under the square root sign. And then BC, in a very similar way, it's going to be 8 minus x all squared plus 4 minus 0 all squared, all under the square root sign. And finally, BA, that is going to be x minus 2 squared plus 0 minus 2 squared, all under the square root sign like that. So using the fact that this is a right triangle, we have the following relationship. AB squared plus BC squared is equal to AC squared. So we have to place these into this. X minus 2 squared plus negative 2 squared plus 8 minus x squared plus 4 squared is equal to 6 squared plus 2 squared. Expanding, this is going to be x squared minus 4x plus 4 plus 4 plus 64 minus 16x plus x squared plus 16 is equal to 36 plus 4. Collecting like terms, you get 2x squared minus 20x plus 48. Bring everything over to one side. We can divide through by 2, and this gives me x squared minus 10x is equal to 24, plus 24 is equal to 0. And I can factor this, and it brings me x, 6, and 4 minus minus. So that gives me two values of x. Okay, let's see here. 6 and 4 are both answer choices. All right, well, obviously, I've got to figure out which one is correct. So how do I do that? Well, this is where this symbol comes into play. That symbol basically tells me that those two sides are equal, right? They tell you that in the question. It's isosceles. So that means that BA is equal to BC. BA is equal to BC. So I've got to use 6 and 4 to figure out what each of these are. First, let's figure out what it is for x equals 4. When x equals 4, this looks like 4 squared plus 4 squared, and that is 32. When x equals 4, this looks like 2 squared plus minus 2 squared, and that is 4 plus 4, which is 8. Okay, so those are not equal. So that pretty much means that x is equal to 6, but let's just figure out what BC and BA are to be sure. When x is 6, we got 8 minus 6, which is 2 squared, which is 4, plus 4 squared. So that's 4 plus 16, which is 20. And then for BA, it would be 6 minus 2, which is 4 squared, plus negative 2 squared, and that is 16 plus 4, which is also 20. So there you go. BC is indeed equal to BA, and therefore x is equal to 6. So number 17, the answer is D. Alfonso and Karen started out with the same number of apples. Karen gave 12 of her apples to Alfonso. Next, Karen gave half of her remaining apples to Alfonso. If Alfonso now has 4 times as many apples as Karen, how many apples does Karen now have? So we've got Alfonso and Karen, and initially they had the same number of apples, so I'll let that be X. And initially, the first step is that Karen gives 12 to Alfonso. So she ends up with x minus 12, and he ends up with x plus 12. Then she gives half of what she has to Alfonso. So she's basically giving him x minus 12 over 2. And he had x plus 12, so now he has this much. So she is left with x minus 12 over 2, right? So half of what she had before. And this, they are saying, is equal in the following way. Alfonso now has 4 times as many apples. So that is the equation we have to solve. So let's solve that. We've got x plus 12 plus x minus 12 over 2 is equal to 4x minus 48 over 2. Multiply through everything by 2, get rid of that fraction. 2x plus 24 plus x minus 12 is equal to 4x. We're multiplying through by 2, so that fraction can disappear. So now collecting like terms, it looks like this is going to be x here. 24 minus 12 is 12. 12 plus 48 is 60. So 60 is not even one of the answer choices. So I was about to say don't choose 60, but you don't have to worry about that. Why? Because they don't want you to figure out x. Well, they do, but what they're asking for in the end is how many apples does Karen now have? How many apples does Karen now have was this guy right here, x minus 12 over 2. So x minus 12 over 2 is what they want you to figure out, and that would be 60 minus 12 over 2, which is 48 divided by 2, which is 24. So the answer is B for number 18, and just to be on the safe side, it takes maybe less than 30 seconds. We can just verify, does this work? X minus 12 is 48, x plus 12 is 72. And then when she gave half of it over, it became 72 plus 24. She was left with 24. This is 96, and 96 is indeed 4 times 24. So that works. In the diagram, ABCD is a quadrilateral with diagonal AC. Which of the following is a possible length for AC? So at first glance, you think, well, there's no right triangle here, and there's no angles, and do I use trigonometry, or do I use law of cosines? What do I do here? I don't know. I'm stuck, right? Perhaps, but some of you, of course, know this special formula called the triangle inequality. And that basically means that in any triangle, if you label the sides, say A, B, and C, A plus B must be greater than C, right? That's the only way a triangle can be made. So let's use that. AC is what we have to think about. So first I'm just going to look at this triangle right here. That means that 10 plus 9 has got to be greater than AC. So 19 has to be greater than AC. So since AC is less than 19, immediately I can get rid of that answer choice. All right. Now I'm going to concentrate on this triangle. In that triangle, any combination of this works, by the way. It doesn't have to be A and B. It could be B plus C has to be greater than A plus C has to be greater than B. Basically, 2 sides, when you add them, have to be greater than the third side. That's the only way a triangle can be made. So using that with this triangle, I will write that 5 plus AC, this side, the diagonal, must be greater than 19. Okay? That has to be true. So now let's go through the answer choices. If AC is 9, 5 plus 9, is that greater than 19? Well, no, because that's 14. 14 is not greater than 19. So that's no good. How about 10? 5 plus 10 is 15, and that is not greater than 19. How about 13? 5 plus 13, is that greater than 19? No, because it's 18, and 18 is not greater than 19. Well, there you go. By process of elimination, we boil down to 15, but 15 is indeed true, because if AC is 15, that means that 5 plus 15 is indeed greater than 19. So number 19, the answer is D. The graph of the function y is equal to ax squared plus bx plus c is shown in the diagram. Which of the following must be positive? Well, first and foremost, notice that this parabola opens downward, right? And if the parabola opens downward, that means this coefficient right here, a, is negative. So a is less than 0. That's the first thing. Now, what about b and c? Are b and c negative or positive? I don't know. Well, we are not given any specific values, right, for the roots. But we can kind of see from this graph that this root right here is positive. Well, let's just say it's 1. I don't know what it is, but it's a positive number. This root here is obviously negative. So let's just say it's negative 3. All right? There is a rule that if you have any polynomial of this form, that the sum of the roots is equal to minus b over a. Okay? So, in this example, you can clearly see that if you were to add these roots, it would be, for example, minus 3 plus 1 approximately, right? And that's going to be about minus 2. And that's negative. So the sum of the roots, minus b over a, in our case, is negative. It's less than 0. Now, we just established that a is less than 0. So how do we get this to be less than 0? The only way is if b is also less than 0. Correct? Let me give you some examples. Let's say a is negative 1. If b is negative 1, then this would be negative 1 all over negative 1, which is negative 1, which is less than 0. If you're unsure, just plug in some numbers to avoid the abstractness of some of these inequalities. Okay, so we've established that a is less than 0 and b is less than 0. Another formula for the roots is the product of the roots. And that is equal to c over a for a polynomial of that nature. And in our case, our roots are 1 and negative 3 approximately. And if you multiplied them, they would basically give you a negative number. Correct? So that means c over a is negative. It's less than 0. Now we just established earlier that a was less than 0. So therefore, c must be positive. Correct? If a is negative, c must be positive for this expression to be negative. All right? Hopefully that was clear. Nothing too confusing about that. So we got a is negative, b is negative, c is positive. Now let's look at the answer choices. We have to find something that's positive. All right, here we go. A, well, a is negative, so it's not positive. B times c. B is negative, c is positive. So BC would essentially be a negative times a positive, and that is equal to a negative. So BC is negative. How about AB squared? A is negative, B is negative squared. A negative squared becomes a positive, and then you're multiplying that by a negative, so that's negative. Now we got B minus C. So we've got a negative minus a positive, and that is going to be a negative. Well, the answer's got to be E, but let's just check. C minus A. C is positive minus a negative, And that basically becomes a positive plus a positive, or negative negative, right? So, and that is of course positive. So finally, the answer to number 20 is E.